Echoing characters is a decent first step, but we always want more. I would love it if I could use my Telnet connection to tell Arduino what to do physically around the world, like switch motors or LEDs on and off and things of that sort. So in this demo I'll show you how to turn on and off an LED and how to read light intensity through a Telnet connection to your Arduino from your computer. You'll need the Arduino Uno, the Arduino Ethernet shield, a photoresistor, an LED, a 1 kilo ohm resistor, and a bunch of jumper wires. In demo 1, it was a very simple application where the Telnet server would just bounce back or echo back any characters we sent through our Telnet client. In this demo, we're going to extend the original sketch and make it respond to instructions that we sent, and specifically get it so that we send a particular instruction like LED on, then this LED is going to turn off, and we can switch it off sending a LED off command. We're also going to be able to take a measurement from this photoresistor, give us a reading of the light intensity in the room. So we'll wire it in and fire the sketch and see how it works, and then move on to the sketch itself and see what's in it. So the LED is going to be controlled by digital pin number 2. I'll use that to turn it on and off. The photoresistor reading is going to come from analog pin 0, and then we'll just plug 5 volts and ground to power the breadboard. Okay, so upload the sketch. Okay, we've been given IP address 192.168.111.177, so I'll copy that and start my Telnet session. Alright, so the sketch now says just type something, type a command and hit return. If I hit return anyway without a command, it gives me the valid commands I can use. So there's photo, LED on and LED off. So I'm going to type photo. So reading is 1023. Now if I type LED on, LED on, and the LED will come on, and I will switch it off by saying LED off. Done. So a very simple circuit. You can imagine that instead of having LEDs, you could have motors, for example, or other types of sensors like a humidity sensor, the DHT22, and all sorts of other things you can attach and then control them via the internet using our Telnet session. So let's have a look at the sketch now. The first part of the sketch is very similar to what we saw in demo 1. So we include the necessary libraries, we provide some default configuration, and then we set up the server to listen at port 23. We also have the already connected Boolean variable. Now I'm saying to the LED that it's going to be connected to digital pin number 2, and I've got a string variable of type called command string. I'm going to use to temporarily store any commands that the Telnet client is sending to the server. We'll see how that works and how it's used in a minute. In the setup function, making LED pin to be an output, then I start my Ethernet adapter. So in this case, I'm not actually using the DHCP service. I'm just starting the Ethernet service by using the the default values that I've specified in the top part of the sketch, so I'm not bothering with TCP starts. It makes the startup of the Ethernet service a bit faster. And starting the server and printing out my IP address. In the loop, just like before, waiting for a client to connect, and when they connect, I initialize my command string, because every time they send a message, it's going to be a new message, so I want to clear up any previously captured commands, and then sending out a message to the new client, some instructions of what to do next. And we'll start picking up one character at a time. So when we do have a connection with a client and they have something to send, then read the character to send, save it temporarily in the new character variable. And this is important because we want to know when the user hits the enter key. So the enter key, depending on the operating system, may have one or two actual characters that are transmitted. But what we are interested about is to detect a carriage return. That signifies that the user has typed in the command and then they want this command executed. So I'll be looking for the carriage return, which according to the ASCII table of characters is a 0D hexadecimal byte. So I'm trying to make sure that once I get that, then I have completely received the command, one character at a time, and assembled. Then the command is going to be stored temporarily in the command string variable. Now, if the Arduino does not receive a carriage return, then what it has received is just another character of the total command. So remember, the commands will be assembled on the Arduino one character at a time. So the character that was read from the Telnet client, unless it's a carriage return, it will be added to the end of any other characters that were captured earlier. So this operator here says that take whatever new character was captured and edit or appended at the end of whatever else we have saved temporarily in the command string variable. So as I'm typing characters, those characters will be added at the end of the command string until I hit the command, so the return key, and that sends out the 0D byte ASCII character carriage return. Once that happens, then we will evaluate the command that the user sent by calling the process command function. The process command function is down here. It receives a string containing the command that the Arduino has received. This piece of string, let us know that it's processing it, and then we have one if block per command that the Arduino can understand. So we've got an if block for photo, LED on, and LED off. So if you want to extend this example to make it possible for it to understand other commands, and you just add more blocks like these. So with the first block, the one that understands or matches the command photo, what we do is that we use the index of function that is available for strings. So remember, command is an object of type string, and according to the documentation, let's have a quick look. Let's go back to language. Let's look for data types string. You'll see that there's a lot of functions available here. One of them is index of. So index of looks for a character or a string inside another string. And if it does find it, then it will return the index, which means the position of that string that we're looking for in the original string. If it doesn't find anything matching the string we are looking for, then it will send back a -1. So In this example, what I'm doing is that I'm searching for the string photo in the string command, and if it does find it, then it will return a number that is 0 or larger. So if the index of function returns a number that is larger than -1, not inclusive -1, then whatever is inside the block will be executed. So first we're going to let the user know that something was received, the photo command was received, and then we're going to send to the server, which means the object representing this telnet connection. We're going to send the message that we are going to be taking a reading from the photoresistor, and then again sending out the photoresistor actual reading. Because we finished with this command, we want to empty our buffer, which is just a temporary variable, holds the command, by putting an empty string in it. And this is as far as I want to go in the process command function. We don't want to continue to evaluate anything else, because what we're looking for we found. So we have a return statement here, which just ends any further execution of instructions in this function. If the command that we issued was not photo, so there was no match here, then the sketch is going to continue and try to evaluate other commands, ready on, and so on. If none of those commands actually match the one that the user typed, then the user will be shown the instructions. So we call the instructions function, which just prints out the available commands that the sketch understands. So that's about it. It's very simple to create a capability on your Arduino to make it controllable via telnet sessions anywhere from the internet. In this this example, of course, right now I'm showing you how it works through the through a connection within my LAN, but you can imagine that we're now talking about IP connectivity, and you could do a what's called a port forwarding on your server to make it possible for a connection from the internet to access your Arduino through your internet router. And I've got some notes about this in the PDF document that comes with the lecture. So what did you learn in this lecture? Quite a lot, I might say. You got through the fundamentals of connecting a host to an Ethernet LAN and to the internet. But most important, you learned about controlling simple components connected to your Arduino using Telnet. It only takes one more step to connect to your Arduino using Telnet from the internet, which will allow you to connect your LED, your motors, or whatever else is connected to it from anywhere in the world. That's the Internet of Things. You can do this by making a configuration change to your home router and enable port forwarding. Wikipedia has a good article about this, which I'm also linking in the lecture notes. I hope you're feeling excited now. How about you try out these exercises to stretch your skills a little more? In the first exercise, add a DHT22 sensor to your Demo 2 setup and extend the repertoire of commands of the Telnet server so that it also returns the temperature and humidity. In a second exercise, add an LCD screen which displays the IP address of your Arduino when it starts up and connects to the network. This way, when you plug in your Arduino into a network for the first time, you're not going to need the Arduino IDE to find out what its assigned IP address is. You can find that on the LCD screen. Once connected, the LCD screen can also display the commands it receives from the Telnet client.